Welcome to Your Math Explained, where we make math simple and clear. My name is Julian, and today we'll look at two problems that revolve around the idea of number sense. The first problem is for grade 9 and 10 students, and the second problem is for grade 11 and 12 students. In both problems, we use facts about numbers that we already know to develop our logical reasoning. Pause the video now if you haven't had a chance to read it. Otherwise, let's jump in. In this problem, we need to figure out how many different stacks we can make with exactly $100. And we can only do this with $2 bills and $5 bills. What we're being told is that each stack has to have at least one $2 bill. So we should start thinking about how to plan around that, because one $2 bill is not good enough. There's no other way to make up the 98. We have to have our $2 bills as a multiple of 5 so that we can make $10 or $20 or $30 and so on. So we should probably create a visual for ourselves so that we can see all the different possibilities. The first column will just be called stacks. This is just going to keep track of how many different types that we could have. The second column will be the number of $2 bills. The third column will be the value from the $2 bills. And then lastly, we need to make up the rest using our $5 bills. So it'll be the number of $5 bills. So we're going to name our first stack, stack number 1. And I can't have just one $2 bill, as mentioned earlier. I would need to have at least 5 of them so that it becomes a multiple of 10. If I have 5 $2 bills, that means that makes up $10. And I can make up the remaining $90 with $5 bills by doing 90 divided by 5, which makes 18 $5 bills. Notice that this 18 doesn't actually matter. We just want to know how many different stacks can be created based on the $2 bill. So if we try the next scenario, so let's say we're working on stack number 2, the next allowable number of $2 bills should be 10. Because I can't go anywhere with $12 or $14 or $16 in $2 bills. It's just not going to work out. I'm going to need at least 10 to make up $20. And then I can fill the remaining $80 with $5 bills, which would leave me with 16. So as we can see, the pattern really is to deal with the $2, and we can make 30, we can make 40, we can make 50, all the way down to $90, meaning that there are 9 cases altogether. We cannot have $100 made of only $2 bills because we have to have at least one $5 bill in the stack. So altogether, we know there are 9 maximum stacks. Pause the video if you haven't had a chance to read problem number 2. This is for our grade 11 and 12 students. Let's dive in. What we notice here is that we need to make the largest possible value from this expression, and the allowable numbers that I get to choose from are all negative. Well, if I can only choose negative numbers, the first thing that comes to mind is that exponents, when they are even, will create positive numbers. So right away, I'm drawn to having -2 and -4 in the exponent positions. So I will write down w to the -2 plus y to the -4. And using our exponent laws, that tells us this is the same as 1 over w squared plus 1 over y to the power of 4. So we see that they will end up being positive numbers. Perfect. Now it's our job to make these denominators the smallest possible. If we divide by a small number, it would make the overall result big. An easy way to see that is just 1 over 10 is definitely bigger than 1 over 100. So we just want to make the denominator as small as possible. So if we're looking for the smallest possible denominators, that means we should be thinking about using -1 and -3, as those are the smallest values. And then we think about the effect on the exponent as well. We would like to create the smallest possible numbers when we insert -1 and -3 with those exponents in mind. The 4 exponent is going to make my number really small because it multiplies by that same number 4 times, whereas the 2 only multiplies it twice. So we should be influenced to put our -3 in the W position so that we don't have as many -3s as we would in the other scenario. And then we'll put -1 into Y. And what we get here is a 1 over 9 plus 1 over 1. So the overall result creates 10 over 9. That is the largest possible value. And that wraps up this week's problems. Check out the problems I've posted for next week's video. Try them on your own first and see how you'd approach them. Problem D is for our grade 9 and 10 students. And then problem E is for our grade 11 and 12 students. As always, if you found this helpful, don't forget to give the video a like and subscribe so that you don't miss the next one.
That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.